You gotta stop doing that, dude.
Since we don't know
Serious.
which particle is described by x1 and which particle is
Sorry about that.
described
I
by
had some lady tell
x2,
me about wishing a happy
we
New
get
Year's.
two
Older
variations for
woman,
each
and give you some of the
individual
variation
waveform.
here. I'm talking about the dog, and we are this far
Since
into
we
this
don't
now.
know which particle
So,
is described by
wow particle.
x1 and which particle is described by x2,
There's a whole lot of calculus involved
we
there to
get
break
two
it down.
variations for
things are
each
going to get
individual
wild, and if
waveform.
dimensional analysis holds true to the projectile or the statistical analysis under the sector of probabilities of masses and weights that carry that kind of force
Let's
and field.
multiply these waveforms together.
Superman being a meter maid.
Here, we have the symmetric wave function for two identical particles in two separate boxes, in two different energy
You almost hear her
states.
laugh a little bit. Cracks on LGBT3.
Let's now place both particles in the same
Ideal.
box and ignore
The
all
problem
the
is
forces
duality
between
on
the two particles.
wave particle. It's both of those things. It's this thing with these extra numbers in them, because then it makes it different in the skew of things and how it moves and how physics works against it, and amounts and proportions via distance, probability. Again, when this thing stretches out square, you would say ipso facto dimensional analysis. If you're watching a baseball game or a nuclear bomb,
of a symmetrical
you rip paper
spatial
from
wave
here,
function.
the pressure wave on this, given the amounts and proportions, would give you
Let's now
a
repeat
rough
this
estimate
again,
of megatons.
but this time with an
A1 Torino
anti-symmetric
scale
spatial
of the
wave
Richter.
function.
Compositions, metals, time of dilation,
Note
traveling
that we
through
now
the
have
Earth.
a negative sign on the right.
But it's on the right, so yeah, trig. It's coming
Let's
around.
now
I need
place
that one
both
and another
particles in
one
the
that
same
does
box.
it, that did the same number
And
time
again,
dilated and
ignore
renormalized.
all the forces between the two particles.
This is your little house, Mario. Engling's angle, a U being in the middle that day, being probability close to Fermilab. The output on
Even
ones
though
and
this is
zeros,
an
or the orientation in
anti-symmetric
which those
spatial
ones and
wave
zeros need to
function,
be in. Sometimes you need
it
to
is
change
now possible for the two
become
particles
hydrogen.
to be in the same box because they have different energy levels.
them. Physics problem now. Well, we're not we know X. This is tough because if you don't get this, this needs to be a
Notice how the
fundamental.
amplitude is zero everywhere
It's part
along
in
the
critical
line
theory
where
of
x1
when
is
the
equal
max
to x2.
zenith of what I could get out of your rookie ass. Sometimes you in there and then the machine gets a little out. We've got it
This
programmed
means
to do
that there is
gravity.
a
There's
zero
self-programmed.
probability of the
It
particles
should
being
work.
at the same location.
To get
And this
particles
creates an
all zeroed
apparent
out in
repulsion
Fermilab, to line
between
them
the
up,
two
coming through
particles.
here through a capacitor, and get organized and have the same charge. Have a little, if the LED,
Keep in mind that we
we
are
got to figure
ignoring
it out for
all
the
the
power went out
forces
for a second.
between
We
the
do
two particles.
it.
Yet we're getting
sorts
an
it out.
apparent repulsion anyway. On the other hand,
100%.
consider the
It's
case
a little
for a
wobbles. We
symmetric
probably did pull
spatial
it off,
wave
but
function.
obviously your first time in the tool shed, top of the mountain,
Here,
bottom of the Marion
we have
Trench.
the
Could be that
opposite
they walked you
situation,
through a leisure.
in that we have a higher amplitude along the line
Maybe.
where x1 is equal to x2.
Ooh, did it get cold in here?
This means that the particles are more likely to be near each other, and we have an apparent attractive force. So, we have an apparent attractive
going.
force for symmetrical spatial wave functions, and an apparent repulsive force for the anti-symmetric spatial
Like
wave
I said, and you're looking at
functions.
this, and you're just catching some
Whether
angle
the total
XYZ
wave
that the graph
function is
calculator can
symmetric
actually
or
handle.
anti-symmetric
Anti-symmetric or
depends
symmetric.
both on the spatial wave function and on the spin.
Yeah, it's coming at you like ones and zeros.
Photons fall into
To
the
make
category
ZBrush
of
do
particles
this,
we call
it's a plane,
bosons,
stretch it up, stretch
which
it down.
always
Well,
have
that's easy to do.
symmetrical
Yeah, and you
total
can
wave
paint out frame by
functions.
frame, painstaking,
This
brute
means that when we
force,
swap the
brutal
labels of
break in
x1 and
gravity.
x2, The total
Or
wave
you could
function
use
stays
you
the
YF
same.
over X this thing with some electrons and get mad at it and do, well, I gotta figure these out. Or
Electrons
once it was
fall
done,
into
born
the
in
category
rule,
of
still
particles we call
hydrogen, dial it back, it
fermions,
figured out.
which always
I'll
have
make it work like
antisymmetric
fusion to
total
make
wave
a stable
functions.
black hole. And
This means that when we swap the labels of x1 and x2,
like,
the total wave function is multiplied by -1. Let's suppose we are dealing with 2 electrons, and let us
Similar to
ignore
me
the
now.
electromagnetic forces. There are 4 different spin combinations.
And here
There are 4 different spin combinations.
Mn non-zero, this is z-axis and this is y-axis. Now when our
We can think of each spin
Do I have the first
combination
one?
as having its own spatial wave function.
our L is
there we
equal
go.
to 1.
In this
and
example,
our ML
both
is
particles
equal
are
to
spinning
0.
up.
So this
Well, that's
is
what we're
for
looking for.
ML
Come on, zoom in.
equal to
You can
0
do it.
This situation.
there we go.
And we will have
Gonna need this. This is kind of
the
important.
distribution like this.
Hello, friends. If you
In
like
this
money,
other
this
example,
song is for you.
Both
Then you're
particles
in it.
are spinning
Then
down.
you're like, you're into the game. You are playing it now. You're down here. A little bit of this. It writes out like this, but you don't need to once you're
In
here,
this example,
because if you've done things
one
correctly,
particle is spinning up and the other particle is spinning down.
and they look the same, but they might be dimensionally different. Given, remember that other loop we were talking about? But you are here running Tesla right
Since the
now.
particles are indistinguishable, we don't know which particle is which, and we get a combination of these two
Interesting.
outcomes as shown.
I saved hundreds on